Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over part 2 of volume 2 of our ACT preparation series. We're going to be looking at problems 6 to 10 in this presentation. If you'd like to get the latest information on the ACT exam, do visit the official website at actstudents.org. All right, let's take a look at question 6. Question 6 is accessing your understanding of the properties of a parallelogram. It reads, in any parallelogram ABCD, it is always true that the measures of angle ABC and BCD, and then we have the options here, either the supplementary, complementary, are each greater than 90, are each 90 degrees, or are each less than 90 degrees. All right, so to get us started, let's take a look at a real quick review of our properties of parallelograms. Okay, so let's just sketch a parallelogram ABC, and then we're going to review what the properties of parallelograms are. Okay, so we have parallelogram A, B, C, D. So these are the properties that you really want to remember before you take the ACT. Okay, so you have to remember the following. We call properties of parallelograms. So the first one you want to remember is that opposite angles are congruent. Okay, opposite angles are congruent, and that's the notation for congruency from geometry. Alrighty, and then you also have to remember that adjacent angles, basically angles that are next to each other, adjacent angles are supplementary. Okay, what does supplementary mean? It means it adds to 180 degrees. All right, and then lastly, you want to recall that opposite sides of a parallelogram are parallel and congruent. All right, opposite sides are parallel and congruent. Okay, now just to help you see that adjacent angles are supplementary, let's take a look at this parallelogram for a second. We're going to make some adjustments here. If I extend this line right here, what we have is, since opposite sides are parallel, we have two parallel lines. Let me redraw that. We have a parallel line here, this line, and this line. These two lines are parallel. So you have a parallel line, two parallel lines cut by a transversal. Okay, so the line segment containing BC is a transversal. Now, if you have two parallel lines cut by a transversal, do you remember what these angles are called? These are corresponding angles. Okay, so these angles are corresponding angles. Now, since these two angles are corresponding, they are congruent. If you have parallel lines cut by a transversal, corresponding angles are congruent. Now, this angle right here is supplementary to this angle right here. These two angles add up to 180. But since this angle is congruent to that angle and is supplementary to this angle right here, ABC, it automatically follows that ABC is also supplementary to BCD. That shows that adjacent angles of a parallelogram, basically angles that are next to each other, always add up to 180 or are supplementary. Okay, so that's just a side points that you want to keep in mind for the ACT. All right, so now let's take a look at the options that we have here and see which one is correct. In this problem, we're looking at angle ABC, and angle BCD, All right, how will we compare these two angles? These two angles are adjacent angles. And what did we say in number 2 of the properties of parallelograms? We established that adjacent angles are supplementary. Okay, so angle ABC and angle BCD are adjacent. All right, and then we also know that adjacent angles of a parallelogram are supplementary or add up to 180. So that automatically follows that the measure of angle ABC plus the measure of angle BCD is what? Is 180 degrees since they're supplementary. Okay, so we can clearly see that the correct answer to question number 6 is option letter F. All right, let's take a look at question number 7. So question number 7, you've been assessed on how to find the LCD of three numbers. Question 7 reads, what is the least common denominator for adding the fractions 4 over 15, 1 over 12, and 3 over 8? I'm going to show you two methods to accomplish this goal, and then whichever one you feel comfortable with, you can apply when you're taking your test, all right? So the first method, method 1, involves using a table of factors. All right, so method 1 is table of factors. Prime factors to be specific. So what we're going to do is the goal here is when we want to find the common denominator of 15, 12, and 8. Okay, those are the denominators. And the lowest common denominator is basically the smallest number that all three of numbers go into evenly. So using the method of table of factors, we're going to decompose the three denominators. So let's start with 15. We're going to decompose it into its prime factors. All right, so 3 goes into 15 5 times. And then 12, we can decompose that. 2 goes into 12. 2 goes into 12 6 times. And then 2 goes into 6 3 times. Alrighty, and then 8 can be decomposed. 8 is even, so 2 goes into 8 4 times, and then 2 goes into 4 2 times. So basically we can write 8 as 2 times 2 times 2. We can write 12 as 2 times 2 times 3. And we can write 15 as 3 times 5. So now we're going to make a table where we're going to organize our prime factors. But there's a specific rule that we're going to implement when filling our tables, okay? The rule is as follows. You can only place identical factors in the same column, okay? That's how you determine what the LCD is. You can also use the table method to determine what the GCF is also, okay? All right, so let's start with the first denominator, which is 15. So 15 has two factors, 3 and 5, so we have the 3 and 5 columns established. When we are placing the factors of other numbers in here, we have to make sure that they have 3 or 5 in order to be placed in the first or second columns, respectively, or we will have to place them in another column, okay? All right, so the next factor that we are looking at is 12, the next denominator. So if we decompose 12 as 2 times 2 times 3, so we have a 3 there, so we can put the 3 here since it matches. And then we can't put a 2 here since this is a 5's column, so we put a 2 here, and then another 2 right there, okay? All right, and then for 8, the decomposition of 8 is 2 times 2 times 3. 2 times 2 times 2, so we put a 2 here, times a 2, and we need one more 2. The first two columns have already been taken by 3 and 5, so we just place it right here. Bam. Okay. Now the LCD is basically what you get when you read down all the factors and multiply them. Okay. The reason why we have it organized in this method is we want to ensure that common factors are not repeated. Okay. All right. So we have 3 and 3. We bring that down as 3, and this is 5, and then we have times 2 times 2 times 2. All you just have to do is multiply all these numbers together, and that will give you your LCD. So the LCD is 3 times 5 times 2 times 2 times 2. We can go 2 times 5 is 10. 10 times 3 is 30. And then 30 times 4 is 120. All right, so the answer is option letter B. Okay, so that's one way to find the LCD. Another way to find the LCD is using the method of completing common denominators. Okay, All right, so let's take a look at this. Method 2. This is much more applicable to, you can apply this to more advanced problems like dealing with rational expressions when you're adding or subtracting rational expressions. Okay, so completing common denominators. All right, so this is how this method works. It's basically the same thing, but it's more visual, shows you exactly what's going on. So we're adding 4 over 15 and 1 over 12 and 3 over 8. Okay, so what we're going to do first is we're going to express just the denominators as a product of primes. So express 15 as prime in its prime factor decomposition form. That's 3 times 5. We already used a factor tree to show that. And then plus 1 over 12 in its decomposed form is 2 times 2 times 3. And then 3 over 8. 8 in decomposed form is 2 times 2 times 2. Okay. All right. So now this is how the process works. We're going to try and make all the denominators identical. All right. But the rule is whatever change you make to the denominator, you have to apply that to the numerator also. All right. So what we're going to do is we're going to look at the denominators and try and make sure that they have everything. They're all identical. Okay. All right. So we're going to start by looking at the first factor in the first fraction, which is 3. Okay. This one has 1 3, which is good. This has a 1 3, which is excellent. This has no 3s. That's a problem. So we have to multiply the numerator and denominator by 3. So all denominators have 3 in common. Now, the first fraction has a 5. So every other fraction should have at least 1 5. Okay. So this has no 5s. We need to fix that problem. So multiply it by a 5, top and bottom. And the last fraction has no 5, so we multiply by a 5, top and bottom. Okay, so every denominator now has a 5, which is good. Now let's move to the next fraction. It has 2 2's. This has no 2's. Oh, that's not good. We need to fix that. So we multiply by 2 times 2 in the numerator and the denominator. This has 3 2's, which is excellent. So it takes care of that. Now let's move to the last fraction. This has 3 2's, so every denominator should have 3 2's since this is the last one, okay? All right, so this one has only 2 2's, no good. We need to multiply it by another 2, so it matches the last fraction. And this has only 2 2's, so we need to multiply it by another 2 so that it matches the last fraction. All right, so you notice now the denominators are common, okay? And that is the LCD. So to figure it out, we're just going to multiply 2 times 2 times 2 times 3 times 5. Okay? And it's the same thing that we have here. So we can go 3 times 5 is 15 times 2. 30 times 4 is 120. And the LCD is 120. Alrighty, question number 8. Here we're looking at the properties. You've been tested on your knowledge of the properties of exponents, how to accurately apply it. Question 8 reads, the product of 2x to the 4th y times 3x to the 5th y to the 8th is equivalent to. So what we're going to do here to get started is we're going to start by reviewing our properties of exponents. Okay, these are the properties of exponents that you must know in order to be able to do well on the ACT, okay? If you'd like to gain access to all the formulas that you must know for the ACTs, just go to mathgotserved.com and you will see the ACT link there, and there you'll be able to gain access to a downloadable sheet of all the must-know ACT formulas in order to score well on your ACT, okay? All right, so let's review some properties of exponents that you should know to do well on the exam. The first one is the product property of exponents. If you have the product of two exponents with the same base, x to the m times x to the n, what you do is you add the powers, x to the m plus n. All right, number 2, if you're dividing two exponents of the same base, The rule is you do what? You subtract the powers. Formula 3. The power of a power. If you have a power raised to a power, okay, all you do is you just multiply the powers, x to the m, n. Number 4, the power of a product. If you have the product of two terms raised to a power, the result is you just distribute the power to the product of factors that you have, x to the m, y to the m. Number 5, the nth root property. If you have the mth root of a term, so basically this is the index of your radical, this can be written as x to the 1 over m as a rational exponent. And then lastly, the reciprocal property. If you have x raised to negative m, this is equal to 1 over x to the m. So when you reciprocate, the negativity goes away. Okay? Or if you reciprocate a term, you take the opposite of the exponent. Now, let's go ahead and solve this problem. We have the product here of two exponents, 2x to the fourth y. So we're going to be applying the product property here, okay? All right, so we're going to be using the associative property and commutative property of multiplication to rewrite this so you can see exactly what's going on, all right? So we can regroup at this as 2 times 3. So you multiply the constants, 2 times 3. And then the variables with identical basis, you group them together. So you have x to the fourth times x to the fifth. And then y, this has no power, so it has invisible power of 1 times y to the eighth. Okay, so 2 times 3 is 6. X to the fourth times x to the fifth is x to the, using the product property of exponents, number 1, 4 plus 5. You add the powers, and then for the y, the same thing, you add the powers 1 plus 8. Okay, so we're using formula property number 1 here. Let's simplify that. Our final answer will be 6x to the 9th power y to the 9th. All right, so that's how you apply the product property of exponents in multiplying monomials. All right, let's take a look at question number 9. Question number 9 is assessing ability to carry out total cost calculations. Okay, question 9 reads, it costs $8 for an adult ticket to a reggae concert and $S for a student ticket. The difference between the costs of 12 adult tickets and 8 student tickets is $36. Which of the following equations represents this relationship between A and S? All right, if you remember, in part 1 of this volume 2, question number 2 involved total cost calculation. So we're going to be using the same formula that we went over in problem 2, in problem 9 also, okay? All right, but before we start, we have to go over what operation the word difference means, because it also plays a role in the determination of our equation. So we're looking at the difference between two costs, okay? The 12 adult tickets and 18 student tickets. So what does difference mean? Let's go over that operation real quick. So you want to remember that difference basically means subtract. Okay? All right. Now let's look at the formula that's going to guide our problem solving process here. Formula for total cost. So the total cost is basically equal to the unit price multiplied by the quantity. All right, so here we have two things we're dealing with. We're dealing with adult tickets and student tickets. So we have two total costs that we're going to be combining to yield the total cost. Okay, and then we're going to be finding the difference between each. All right, so based on this problem, the difference between the cost of adult and student tickets is 36, right? So this is the problem in word form. Let's now rewrite it using symbolic notation. But in order for us to do this, let's break it up first. So we're looking at the difference between the cost of adult tickets and student tickets. So in order to do that, we're going to be looking at the absolute value of the total cost of adult tickets, and we're going to be subtracting the total cost of student tickets. We're using the absolute value quantity operation here because we don't know which is bigger, okay? If we put in the absolute value, we're guaranteed to always get 36, regardless of which is bigger. That's what the absolute value sign is. Therefore, don't let it confuse you, okay? It's not that important. All right, is in symbolic notation is equal to 36. All right, so in this scenario, we have two total cost calculations that we're going to be carrying out. The first total cost calculation involves the total cost of adult tickets. The total cost of adult tickets is basically the unit cost of adult tickets, or unit price, multiplied by the quantity. Okay, so we're going to be multiplying for the adults the unit price for adults times quantity of adult tickets. That's what we're looking at. So that's the total cost of adult tickets, okay? And then for student tickets, the same. We're going to be multiplying the unit price for student tickets. We're going to be multiplying that by the quantity of student tickets that were bought, okay? And that is equal to 36. All right, so let's set it up. What's the unit price for adult tickets? Let's go up to the problem. For adult tickets, it says it costs $8 for adult tickets. So we'll put that down. We have A for the unit price for adult tickets times the amount of adult tickets bought is 12. Okay. And minus the unit price for student tickets is S, and the quantity of student tickets is 18. Okay. So this difference is equal to 36. Let's go ahead and write our answer in standard notation. So for this problem, the answer is going to be, you put the coefficients first, right? So 12a minus 18s is equal to 36. So the answer is option letter C. All right. Okay, so let's take a look at the other options real quick just to see why they're there. Option A is the quotient. Okay, here you're dividing, so remember division is quotient. So option A is your quotient, and let's see, so option A is quotient, and then option B is the product. All right, so option A is a quotient, option B is a product. All right, so remember, product means multiply. Okay, so product is multiplication. That's what's happening with B. Option A is the quotient, which is division. Option C is the difference, minus, which is what we're looking for. Option D is the sum, which is addition. And option E is not applicable here because the setup is wrong. The amount, the quantity and unit price combination is inaccurate here. You're multiplying the quantity of students with the unit price of adults, which is wrong. Okay, so option E is not even applicable to this situation. All right, so the correct answer is option C, since we're looking for the difference, which represents subtraction. All right, let's take a look at the last one in this series. So for question number 10, we're going to be looking at the um, properties of radicals. How do you simplify radicals? That's what we're looking at here. All right, so the question is, if x is greater than 1, then which of the following has the least value? Okay, so we have 5 options here that we're going to be comparing. So x represents infinite possible set of numbers because we're looking for all numbers that are greater than 1. All right, so if you have a problem like this where we are comparing a variable that meets certain conditions, the strategy will be to pick a concrete variable that's favorable to work with and meets the conditions, and just test it and then see which option meets the conditions that you're trying to test. All right, so here we're looking for which is the smallest. So this is a strategy that we're going to employ for this problem. We are going to pick a number that is greater than 1, and since we have square roots here, we're going to pick a perfect square. All right, so since most options that we're looking at here, since most options are square roots or involve square roots, since most options involve square roots, we're going to pick a small square root that satisfies the conditions, satisfies the initial condition, and test it. Okay? Test it. All right, so what's a good candidate here? We have a lot of perfect squares. We have 1 square is 1, 2 square is 4, 3 square is 9, the list goes on and on. But we're looking for x to be greater than 1. Okay, so what is a good candidate to use here? We have to use something that's bigger than 1. We can't use this one, right? So we can use 4. So we're going to let x be 4. Okay, so let x be our test dummy for this problem. Okay, let x be 4. Why? Well, since 4 is greater than 1 and it's a perfect square, so it works nicely. Now let's go ahead and test it out. F square root of x is going to be square root of 4. The square root of 4 is 2. So you see why we selected the perfect square, right? It makes our computation easy. G, how does it compare with the square root of 2x? Square root of 2x is the square root of 2 times 4. Using the properties of radicals, we can break this up into root 2 times root 4, which is equal to root 2 times the square root of 4 is 2. And you can use your calculator to work this out, but square root of 2 is around 1.414. So it's approximately, we just guesstimating, okay? So it's approximately 1.41. So if you double that, you get 2.82. You can check this with your calculator. Remember, you are free to use a calculator on the ACTs, okay? But you can complete the entire ACT without even touching your calculator. That's how cool the test is. All right, square root of x times x is the square root of 4 times 4. Using the properties of radicals, this can be written as root 4 times root 4. If you root both of them, that's 2 times 2. 2 times 2 is 4. Option J, x root x. Let's substitute our test value 4 in there. So 4 root 4. How does it compare with the rest? This is 4 times. The square root of 4 is 2. 4 times 2 is 8. And then lastly, k, x times x. X times x is going to be 4 times 4, which is equal to 16. Now, since we use a concrete test value here, we can easily compare the results to see which is the least. So the smallest out of all of them is option F. Okay? Square root of x is the smallest. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the ACTs, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests that will help you do well on the ACT, just place your questions in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis, so subscribe so you can get notification of future updates. If you'd like to gain access to a wide variety of support resources to help you pass the ACT, do visit our website at mathgotserved.com or also take a look at the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.